Similar to other effects, electric current also produces magnetic effect. The magnetic effect of electric current is known as electromagnetic effect. In 1820, a physicist, Hans Christian Oersted, learned that a current flowing through a wire would move a compass needle placed beside it. This showed that an electric current produced a magnetic field. Let's perform an activity to know what Oersted found out. Instead of actual compass, we will use needle compass made from everyday things. Take a single double A 1.5 volt battery and place it in the circuit as shown. Needle compass is placed next to thick copper wire. When circuit is complete, current flows through the copper wire, which results in generated of magnetic field around it. This field moves the needle of the compass, which itself is a magnet. Changing polarity results in needle getting deflected in opposite direction. This activity enabled us to understand how magnetic field is generated due to electric current. Now let's do some activities based on this principle. An electromagnet is a magnet that is created using an electric current. Since electricity can be turned on and off, so can an electromagnet. It can even be weakened or strengthened by decreasing or increasing the current. Electromagnets are used in all kinds of electric devices, including hard disk drives, speakers, motors, as well as scrap yards to pick up heavy scrap metal. Let's look at the simulation and understand how this works.
An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. The magnetic field disappears when the current is turned off. Electromagnets usually consist of wire wound into a coil. A current through which the wire creates a magnetic field which is concentrated in the hole in the center of the coil. An electromagnet requires a continuous supply of current to maintain the magnetic field. Though wire turns are often wound around a magnetic core made from a ferromagnetic to make it stronger. We will not use the same in this simulation. When current flows through the coil, magnetic field is produced around the coil. Let's visualize the same. Using the voltage slider, we can increase or decrease the voltage. Direction of the current can also be changed. Increasing the voltage results in increasing the current, and field becomes stronger. Reversing the polarity of the battery reverses the direction of the magnetic field as well.
Let's perform a couple of activities to see magnetic effect in action. Plastic bobbin used in sewing machine is taken for winding copper wire. Copper wire is 35 gauge coated wire, similar to one used in electric motors. You can procure the same from the electric motor repair shop. Around 900 turns are wound round the bobbin. Sandpaper is used to remove coating in the wire from both ends. This will ensure that current flows through the coil when battery is connected to both ends. Metal pin and thick and bare copper wire is used to build a circuit. This part of copper wire acts as a switch. 9-volt battery is used as source of electrical energy. Small copper loop enables switching of circuit on and off. When circuit is complete, current flows through the copper winding in the plastic bobbin. This results in it becoming a magnet. This attracts the iron nut placed below it. When nut is lifted, it reaches the farthest end and lifts the small copper loop, thus breaking the circuit. After the circuit is broken, copper winding loses its magnetism and nut falls down. This cycle continues forever. Placing it on the large container produces a nice sound like an electric bell at home. Do try this at home. Try changing the types of container, the size of the container, and strength of the battery. These large cranes are used to pick up and move metals containing things such as steel and iron, which is primarily found in recycling plants and junkyards. The electromagnetic cranes work by using a magnetic field that is created by an electric current that can be turned off and on whenever it is necessary. The electromagnet consists of an iron middle with a wire wrapped around it, which is where the electric current travels. Let's try building a similar electromagnetic crane. Iron nuts and washers are used to build a spool-like structure. Around 500 turns of coated 340 gauge copper wire is wound around the same. Cycle spools, school compass, box, and bottle caps are used to build the trolley mechanism. For AA batteries are connected in series to get effective voltage of 6 volt. Completing the circuit turns nut and washers assembled into electromagnet. The electromagnet is used to lift pins. Try building similar crane based on electromagnet. You can increase the number of turns and make a stronger electromagnet.